Welcome to the Explainer. If you're tackling the electrical technician exam, you are in the right place. We're going to do a high-speed power review, breaking down 20 real questions to find the patterns and principles you absolutely need to know.
Whoa, okay, let's dive right in with a real question from a past exam. Look at this thing. Non-sinusoidal voltage, multiple harmonics. I mean, at first glance, this looks pretty intimidating, doesn't it?
But hey, don't sweat it. The goal here isn't just to solve this one problem. It's to show you the core concepts behind this one and 19 others. We're going to build your confidence for exam day, right here, in the next few minutes.
First up, let's tackle AC circuits. You know, this is the bread and butter of the exam, and nailing these common question types is absolutely crucial. Okay, the exam loves to test core definitions, so let's lock these two in right now. Reactive power? Just remember, it's the one that uses sine. Got it? Sine. And the time constant for an RL circuit? Super simple ratio, L over R. Boom. Knowing those cold is like getting 2 free points on the board. All right, now here's a classic they love to throw at you. An RLC series circuit. They give you R, XL, XC. Take a look at those values. What's the very first thing that should be screaming at you? Exactly. The inductive and capacitive reactances are identical. It's a resonance circuit. Think of it like a perfect tug of war, where they just cancel each other out. And what does that mean? It means the circuit's total impedance is just the resistance. So this scary-looking RLC problem, it boils down to simple Ohm's law. 100 volts divided by 10 ohms, 10 amps. Done.
You can bet you're going to see polyphase systems on the exam. It's a guaranteed topic. They'll hit you with Y connections, delta connections, you name it. So this one, it gives us line values and asks for phase values in a Y connection. So how do those two relate?
Okay, this chart right here, you need to burn this into your brain. Seriously. But look at the Y connection row for this question. What do you see? The line current is exactly the same as the phase current. So if the line current is 10 amps, guess what? The phase current is 10 amps too. No math needed. That's a gimme.
All right, let's wrap this section up with 2 quick-fire facts. These pop up all the time as easy multiple-choice questions. Fact 1, a perfect, pure sine wave has 0 distortion. 0. Fact 2, the frequency of a harmonic, it's just that number times the fundamental. So the third harmonic is simply 3 times the base frequency. Easy peasy.
Okay, let's keep the momentum going. Section 2, we're going to see how all these electrical ideas build into the world of electromagnetism. Now we're talking fields, forces, all that good stuff. So here is a typical electromagnetism question. They give you turns, current, and then they throw in extra info like the core material or its size. Why? To mess with you. But to find the magnetomotive force, or MMF, what's the only information you actually need to pull out of there? The key here is knowing the formula. F equals N times I, turns times current. That's it. All that other stuff about the iron core, it's just noise designed to distract you. You just multiply 600 by 0.5 and there's your answer, 300 ampere turns. See? Spotting the right formula is half the battle. You're also guaranteed to see a question on identifying magnetic materials. Just remember the scale of attraction. Diamagnetic? They're actually repelled, just a little. Paramagnetic? Weakly attracted. And ferromagnetic? That's the big one, strongly attracted. Think F for ferocious attraction, like with iron.
When a question about the hysteresis loop comes up, it's almost always about what the axes represent. Just lock this in. H, the field strength you apply, is on the horizontal x-axis. B, the flux density you get out of it, is on the vertical y-axis. H goes in, B comes out. X then Y.
Okay, I'm not gonna lie, this section is definitely formula heavy. Success here really does come down to good old-fashioned memorization. You've got to have these 3 on instant recall: Coulomb's law, the Biot-Savart law, and especially that simple one for energy in an inductor.
All right, home stretch. For our final section, we're going to nail some of those key laws and specific named effects. You know, the ones that show up as brain teasers or conceptual problems instead of pure math. This one, this is a classic, a true classic conceptual problem, and it tricks so many people. You've got a 100-watt bulb and a 200-watt bulb in series. Which one is brighter? Your gut reaction is probably to say the 200-watt one, right? But let's actually walk through the physics.
Okay, let's break it down step by step. Step 1, Remember that power equals V squared over R. That means the lower wattage bulb, the 100-watt one, actually has higher resistance. Step 2, they're in series, right? So the current flowing through both of them has to be identical. And step 3, the formula for actual power burned is I squared R. So if I is the same for both, the one with a higher R, our 100-watt bulb, is going to dissipate more power. And that means it's the one that shines brighter. Wild, right? You're also going to get questions that are just pure name association. They'll give you a description, you give them the name. You need to know that Faraday's law of electrolysis is all about mass and electric charge. And the Peltier effect, just think cooling. That's the magic behind those little electronic coolers and refrigerators. Sometimes they just want to know if you know your material properties. So if you get a question asking for the lowest relative permittivity, just picture a simple chart like this. You can see right away that air is the baseline. It's going to have the lowest value compared to common insulators like paper or mica. And for our final concept, burn this into your memory because it's an absolute rule. Electric field lines always cross equipotential surfaces at a perfect 90-degree angle. They are always perpendicular. So if you see an answer choice that says they run parallel or they don't cross at all, you know it's instantly wrong. Okay, we just did a full-on sprint through 20 different kinds of exam questions. AC circuits, magnetism, fundamental laws, you name it. So after seeing all of that, what's the big picture takeaway for your final study sessions? You know, it really boils down to this 3-part strategy. 1, know your formulas. Drill them until they're second nature. 2, understand the why. Don't just memorize that reactances cancel at resonance. Understand why it happens. And 3, learn to spot the patterns. Recognize a series circuit problem or a resonance problem the second you see it so you know exactly what to do. All right, we have covered a ton of ground, and fast. So I'm going to leave you with one final question to guide what you do next. Based on everything we just flew through, what's the #1 concept you feel you need to go back and review? Whatever just popped into your head, that's where you should start. Now go get 'em. Good luck.